Students, I welcome you all to the second session of grid security. In the first session, we have seen the introduction about grid security. Now we have the concepts of cryptography. It is used to protect network and data transmission. Cryptography uses set of algorithms to encrypt and decrypt the messages. So, it is the process of converting ordinary plain text into unintelligible text and vice versa. In grid security, cryptography plays a vital role to ensure confidentiality, message integrity, sender authentication and non-repudiation. So, to achieve the above set goals, various crypto techniques are implemented. Now, let me simply explain these processes. First one is confidentiality. It is a very simple one. The encryption algorithms are used to convert the plain text and authorized recipient can extract the encrypted data. The second one is integrity. Integrity of message means the recipient has the mechanism to identify if the message has been altered. And the next one is authentication. Here, the recipient can verify the authenticated sender, whether the sender is authenticated person or not. So, with the help of the authentication technique, he can check the originality of the message. And the last one is non-repudiation. It assures that someone cannot deny the validity of something. That means it provides the proof of the origin and integrity of data. In the next coming slides, we are going to discuss about the types of crypto systems, that is symmetric crypto system and asymmetric crypto systems, digital signatures, public key certificate, certification authority, and something about firewalls. Now let me explain the concept of symmetric crypto systems. Here, both encryption and decryption algorithms use same key for encoding and decoding. That is common key shared by sender and receiver. Here, checksum is applied in cryptography. You know that it is a mathematical value, that is checksum is a mathematical value that is assigned to a file and used to test the file at a later time to verify that the data has not been maliciously changed. I think you have very clear idea about the checksum because we have learned this very clearly in the network security paper itself. So, the symmetric encryption protects confidentiality and data integrity. Data encryption standard is the good example algorithm for the symmetric crypto system. DES consists of two components, that is an algorithm and a key. This algorithm involves a number of iterations of a simple transformation which uses both transposition and substitution techniques applied alternatively. You have very clear idea about transposition and substitution techniques, I hope. So I move on to the next topic, that is asymmetric crypto systems. Asymmetric crypto systems, it is somewhat different from symmetric crypto system. In asymmetric, we are using set of two keys, that is private key and public key we are using. The encryption and decryption are performed using a pair of keys such that knowledge of one key does not provide the knowledge of the other key in the pair. So one is public and another one is private. We usually have public key in encryption and private key in decryption. So the main advantage of this technique is the secrecy is not needed for the public key. The public key can be published rather like a telephone number. The RSA algorithm is very suitable for a symmetric crypto system. Actually, this algorithm is developed by Rivest, Shamir and Adelsman of MIT University. They are the developers. This algorithm provides authentication as well as encryption with the help of two keys. The keys for the RSA algorithm are generated mathematically in part or by combining prime numbers. The security of RSA algorithm depends on the number of bits used in the key. Usually the length of the key may be 256 or 512 bits. Next, we have a discussion about digital signature. Now let me explain digital signature. Digital signature is similar to the signature in a document to authenticate. Usually, integrity is guaranteed in public key systems by using the digital signature. This is a method of authenticating digital information. The digital signature is itself a sequence of bits conforming to one of a number of standards. Most digital signatures depends on public key cryptography to work. Often, a cryptographically strong hash function is applied to the message and the resulting message digest is encrypted instead of the entire message, which makes the signature significantly shorter than the message and saves considerable time. Because hashing is generally much faster byte for byte than public key encryption. The next is public key certificate. It is a file that contains the public key along with identity information such as person's name, all of which is signed by certification authority. The certification authority is a guarantor who verifies that the public key belongs to the named entity. What is the need to have public key certificate means? To avoid the unauthorized issue or creation of public certificate. It must be generated and authenticated by the proper authority. That authority is called CA, that is certification authority. So he is responsible for issuing and revoking certificate for public keys. The certificates are required for the large scale use of public key cryptography, since anybody can create a public or private key pair. If the originator only trusts public keys that have been signed by an authority, then some type of attack can be prevented. In large-scale deployments, one user may not be familiar with another certification authority. So, in such scenario, a higher level certificate authority may issue the certificate. A certificate usually contains the public key, the name and validity period, and finally the URL of a revocation list. The most common certificate standard is the ITU TX.509. The common syntax of this standard is subject, subject's public key, issuer's subject, and finally digital signature. So in the previous slide we have seen the public key certificate. The certification authority is responsible for issuing the certificate. So he provides the entities with a trustable digital identity. It may be an individual or an agency or anybody who is ready or who is eligible to provide the certificate in authorized form. This certificate authority can issue certificate and make valid certificate and revoke certificate if necessary. A certificate authority can issue personal certificates to users. The meaning or the use of this personal certificate is to allow the users to identify themselves to remote entities. So a personal certificate can also be used for digital signature. A certificate authority can also issue server and service certificates. Each server and service connected to a network must be able to identify itself. A certificate authority issues public key certificates that state that the CA trusts the owner of the certificate. The last one is firewalls. Firewall is nothing but a software or a hardware component to ensure administrative policy. Usually, traditional firewalls monitors the boundary of two or more networks, and personal firewall is a software application which filter or monitor a single computer. Firewalls usually prevents intrusion in network. Intrusion means fraud or unauthorized related work. Next, the firewalls operates at network layer and application layer. A network layer firewall operates at the network level of the TCP/IP protocol stack. It undertakes IP packet filtering, not allowing packets to pass the firewall unless they meet the rules defined by the firewall administrator. The application layer firewalls operate at the application level of the TCP/IP protocol. The firewalls can prevent all unwanted traffic from reaching protected machines. We can say proxy server can act as firewall in most of the institutions and IT companies. Thank you. Thank you for watching the video. I hope you are very much clear in cryptography and its subtopics. Thank you.